C2 integration example 4. So here we're given the curve y equals x times x plus 1 times x minus 1. And we're asked to find the area between the curve and the x-axis. So the first thing I'm going to do is draw a graph. So I've got my y-axis and my x-axis, and the graph will look something like this. Where of course I'm cutting the x-axis at -1, 0 and 1. So as you can see, the area that I'm trying to find is this area here between -1 and 0, and this area here between 0 and 1. Sorry about that. This area here between 0 and 1. So I'm going to just expand out my equation, so that would give me y equals x times x squared minus 1, which gives me y equals x cubed minus x. So I want to integrate between -1 and 0, x cubed minus x with respect to x, and then I want to add on the integration between 0 and 1 of the same equation. So that's x cubed minus x with respect to x. So when I integrate this, I get add 1 to the power, x to the power of 4, divide by the new power, so divide by 4. And then the same with the x, so that's minus x squared over 2. And I want to evaluate this between -1 and 0 and add on the same integral, but this time evaluated between 0 and 1. So the first thing I wanted to do, remember that you substitute in your top value first. So when I substitute in x equals 0, I just end up with 0 minus 0. And then when I substitute in -1, I get minus, well, that would give me a quarter, substituting in -1, minus a half. So a quarter minus a half gives me minus a quarter, but it's minus minus a quarter, so that just gives me the area of a quarter. So next, I need to add on the evaluation of this, so that'll be a quarter minus a half, evaluating it at 1, and then if I subtract the evaluation at 0, that just gives me 0. But here we have the area of minus a quarter for the evaluation between 0 and 1. But of course, that's only because it's underneath the x-axis. So from this second part here, we get minus a quarter, but the actual area is a quarter. So instead of subtracting a quarter from a quarter, we're going to add the quarter on, because it's just an area plus an area. So that gives me a total area of a half.